Liquid just killed the GPU tax on encoders. Nobody in your feed is talking about it. Your embedding bill is the receipt. I am Stewart. 5 drops this week, 4 of them matter. 1 is the rewire I am shipping in my own stack by Friday. Liquid dropped an encoder that beats models 10 times its size on your laptop CPU. Unsloth dropped Kimi K3 GGUFs for local rigs. Microsoft dropped a 4 billion parameter image model that eats 20 billion parameter models for breakfast. SWE-Rebench went multilingual, and half of you are picking coding models off a benchmark that lies to you. And the last one, the one nobody saw coming, is what Alan AI just did to the price of continent-scale AI. Start with the one that changes your Monday. Liquid AI released LFM2.5 encoders yesterday, and if you run any kind of retrieval, classification, or routing, you need to sit up, open the Hugging Face page. The 230M and 350M models went live July 28th. Downloads are already past 4,000. The context window is 8,192 tokens. A full contract, a long email thread, or a hefty knowledge base chunk in one forward pass. Here is the API response I pulled 2 hours ago. Model ID confirmed. Creation date July 27th. Last modification yesterday. 4,115 downloads. Config confirms the bidirectional masked LM architecture. Block DIM of 1024, exactly as the model card advertises. On CPU at 8K tokens, ModernBERT base takes over 90 seconds. LFM2.5 encoder 230M takes 28, 3.7 times faster on the same hardware. And the 350M version ranks 4th out of 14 models across 17 tasks from glue, superglue, and multilingual benchmarks. The 3 ahead of it are all bigger. One is 3.5 billion parameters, 10 times its size. Open huggingface.co/liquidai/LFM2.5 encoder 230M yourself right now. Look at the CPU latency chart in the model card. The 28-second figure is on the page. Verify me before you take my word. Here is what it actually means for your stack. If you are still paying OpenAI or Cohere for embeddings over documents you already own, you are lighting money on fire. Fine-tune LFM2.5 encoder 230M on your corpus, run it on the CPU box you already rent, and your marginal cost per embedding call drops to electricity. Rough math. 100,000 documents at 8K tokens through OpenAI's text embedding 3 large runs you around $13 just to backfill once. Rerun it monthly on a corpus that changes, and you are into hundreds a year on a one-off job. On a 32-core CPU box you already have, at 28 seconds per 8K pass, the same backfill runs overnight for the cost of electricity plus your own time to set up the fine-tune. The break-even is aggressive, the catch is real. Liquid did not publish which CPU produced the 28-second number. No ONX or OpenVINO export exists yet. The loader requires trust remote code equals true, which some enterprise environments block outright. Ship it in a dev cell first. And if you think that is the wildest local inference story this week, wait until I tell you what Unsloth just did to Kimi. Unsloth started dropping Kimi K3 GGUFs, frontier tier open weights, ready to run on the rig sitting in your office. Kimi K3 is the latest checkpoint out of Moonshot AI, and up until this week you needed serious infrastructure to run it. Unsloth is the team that made Llama 3 and Quinn actually runnable on consumer hardware. They quantize aggressively, they patch loading bugs on day one, and their GGUFs plug into llama.cpp, Ollama, LM Studio, and Yan without ceremony. The specific quant sizes and VRAM requirements are still being posted as I record. I could not lock down the numbers from the source without hitting a Reddit verification wall, so verify the exact quant you want before pulling it. What I can tell you from every previous Unsloth drop is the pattern. Q4KM usually holds quality close enough to full precision that you will not feel the difference for most work. Q2K is where quality starts leaking. On the hardware side, if you have a 24 gig 4090 or two 3090S bridged, you are in Q4KM territory for a model this size. If you are sitting on 12 gigs, you will be in Q3 or lower, and quality will start showing cracks. And the window matters. The first 2 weeks after an Unsloth GGUF drop is when the community catches loading bugs, when the tokenizer quirks get patched, and before hosted serving pushes prices down enough that local stops paying back. If you are going to try Kimi K3 on your own hardware, the next 14 days is the operator window. And while we are on the theme of small beating big, Microsoft just embarrassed the entire 20 billion parameter image model club. Microsoft quietly dropped Mage-Flow, 4 billion parameters, a 1024 by 1024 image in 0.59 seconds on a single A100. Open microsoft.github.io/mage/flow. Mage-Flow Turbo scores 0.88 on GenEval and 0.873 on CVTG2 KK. Image sits at 0.87 on GenEval. KB image is 20 billion parameters. Mage-Flow Turbo is 5 times smaller. A slightly better score. And the edit variant, Mage-Flow Edit Turbo, beats FireRed Image Edit 1, 0 and KV Image Edit 2511, both also 20 billion parameters, on the G-Edit benchmark in English and Chinese. The Mage-V tokenizer alone cuts encode max per pixel by roughly 12 times, and decode by 22. Microsoft's way of saying the bottleneck was never the diffusion loop, it was everything wrapped around it. Caveat: the benchmarks are Microsoft's own numbers under their own unified protocol. Third-party GenEval reproductions are not in yet. Treat the 0.88 as a claim, not a settled result. But even accounting for marketing gravity, if you are running an image generation pipeline in production, and you have not benchmarked Mage-Flow Turbo against your current 9 to 20 billion parameter model on your own prompts, you owe yourself a 2-hour test. The GPU rent delta on a 4 billion model at that quality is where your margin lives. If the operator take is the kind of thing you want in your feed weekly, hit subscribe, 5 seconds, it costs you nothing, it keeps this channel doing this instead of another top 5 recap. And on production, if you are picking your coding model off SWE-Rebench right now, I have bad news. SWE-Rebench just went multilingual. Go Java, Python, and your Python only leaderboard is misleading you. SWE-Rebench is the continuously updated coding benchmark run by Nebius, where SWE-Bench takes a frozen slice of GitHub issues and asks a model to fix them. SWE-Rebench pulls fresh issues on a rolling window, so models cannot silently train on the eval set. Last week they added multilingual coverage. Go, Java, Python, all three on the same protocol, same scoring, same task shape. Here is why an operator cares. Every coding model leaderboard in your feed for the last 18 months has been Python first. It worked when Python was the default. Now a lot of you are shipping Go services and Java backends, where the model that wins on Python does not necessarily win. The failure mode is subtle. A model can memorize idiomatic Python patterns from training data and look brilliant on SWE-Bench, then fumble a Go interface satisfaction check or a Java generics quirk in production. Cross-check the multilingual leaderboard before you commit a coding model to your CI loop. If your team ships in more than one language, single language benchmarks are a broken measuring stick. The SWE-Rebench update is the operator's fix. And the last one is the drop nobody outside the geospatial world is talking about. The number attached to it should change how you think about what AI at scale actually costs. AI released the OlmoEarth platform yesterday. The price they attach to continent-scale AI inference is what closes this video. OlmoEarth runs geospatial inference at continent scale in about 1 day, fractions of a penny per square kilometer. Their North America wildfire risk run used roughly 19,600 CPUs and 994 GPUs in parallel, hit 168 gigabytes per second in network throughput, and compressed 4,737 serial compute hours into 30.5 wall clock hours, a 155 times speedup. And the whole thing is open infrastructure. You might not touch geospatial workloads and think it is safe to skip. Read the number again, fractions of a penny per square kilometer at continent scale. What AI has just published is the reference architecture for doing planet-scale inference on your own terms. Not on Google Earth Engine's terms, not on AWS SageMaker's terms, on yours. Even if your domain is not satellite imagery, the orchestration pattern, the CPU-GPU split, the parallelism math, all of it transfers. Anyone running batch inference over any large corpus, text, video, audio, sensor, the shape of your next architecture looks like this when you stop paying serverless premiums for jobs that were always batch. Every story I covered today rhymes. Liquid, Unsloth, Microsoft, Nebius, AI. All of them are quietly moving compute back to the operator. Smaller models, local weights, honest benchmarks, reference infrastructure. The window to move on any of this is short. The people who ship one rewire by Friday spend the next quarter on margin. The people who wait for a Verge write-up spend it catching up. Everything I broke down today, the exact fine-tune recipe I am running on LFM2, 5 encoded 230M this week, the quant I am pulling for Kimi K3, the prompt set I am testing Mage-Flow Turbo against, all of it lives in the Church of SEO Jesus, my free school community, free to join. Link is in the description and pinned comment. Get in before this week's thread closes. Next video I am tearing down the CPU box specs I am running this stack on for under $100 a month.